girl, you know I love the way you dance.
These are two pieces of glassware that have been used for the TOPP test. As of right now, the condition of this glassware is assessed subjectively. So people will look at the glassware and say, visually, this is a lot dirtier than this, so therefore it's in worse condition. Now with these two samples specifically, that's not much of a problem. But when you have samples with oil deposits that are very similar in color, it can be very hard to see visually which the better sample was. Which is why this summer I've set out to create an objective metric via standardized procedure to determine the condition of this glassware. Let me walk you through it. Now, the first thing I wanted to prioritize with this procedure was making sure that every single time we went to analyze a piece of glassware, it was exactly the same as the last time. So what that means is I've set up a light box to optimize the physical condition. So this is gonna remove the majority of reflections on this piece of glassware, which you'll see momentarily why that's so essential. And then I've also set up a tripod that's currently used to take this video, otherwise it would be right here. And this tripod is at uniform distance from the light box, so it's the same every single time. And essentially, this procedure goes as follows. You're gonna put in the baseline piece of glassware. So this is your cleaner sample. And then once this baseline is in, I would take a photo with the tripod and then go in and analyze that photo with a photo editing software that's gonna determine the average color of the whole tube. And once I have this average color determined, I can put in the dirty piece of glassware. And once I put this dirty piece of glassware, I will repeat the process and then get the average color of this and then use a formula called delta E, which I have up on the whiteboard here. And this formula is gonna determine the distance in total color that the dirty sample has from the base sample. And what this is gonna tell us is a dirtier sample is gonna have a higher delta E value, giving us an objective metric to say that this sample, for example, scored a 42.5, and this sample scored a 44. So therefore, this sample is the cleaner of the two and the better sample. Now, when the condition of glassware is being analyzed, there's two very important parts of the glassware that we look at. First, we have the fluid space down here. This is where the oil actually goes when conducting the TOPP test. And secondly, we have the head space up here. These are two very important separate metrics that we need to quantify. So during the procedure, we take separate measurements for the average RGB and CIE LAB value of the fluid space and the head space. Once I've taken my photos, I just load them into Photoshop or whatever your photo editing software of choice is. And I crop the image so that just the fluid space and the head space is available for both samples. And then I'll load it into a third-party software and determine the average color of that whole area. Once I've done this, I simply convert that value to a CIE LAB, and I use the delta E formula, which spits out a number, and this number will give me a very quantifiable metric to determine the condition of TOPP glassware. The higher the number is, the bigger discrepancy there is between the baseline and the testing piece of glassware. And the lower the number is, the closer in color the testing piece is to the baseline. So a higher number will equate to a potentially dirtier piece of glassware, and a lower number will mean that the glassware is cleaner and closer to the baseline.